Okay, so last video we talked about third order example, so now we talk about third and second order example. Actually second order example. Okay, so what we're gonna do is actually do why do you not do first order? Later I'll just show you, but now straight away go to second order. So remember our rules. First we need to set our transfer function into a closed loop negative unity, which is the gs over 1 plus gs, okay? G over 1 plus kd nonetheless. In this case, k is any real number. I mean, this is a controller actually. Is how they actually put. You can actually put gs over 1 plus gs, as I said earlier. I'm not gonna go in depth about it anymore. So gs is equals to so this dude over here over 1 plus gs, okay, is equals to, and then you expand, you just multiply s over s plus 2, s times s plus 2, you just multiply the whole system. We didn't change anything, you're just, rearranging the interior itself. So eventually you'll get this field over here. So you need to really practice how to get this. I'm going to talk about it. And then once you get this, you know that, okay, dude, this is the second order, the highest order is the second order. So what are you going to do? So what you're going to do is to determine the whether order, right? So you determine already. So third, we have to determine our criterion. So our criterion says that if you are a second order, okay, because in second order systems, all coefficients have to be positive. So do we have coefficients to be positive? So as you can see, all are positive, so we are happy. So with this, and then we can straight away determine the range of k already. So we have to make sure k must be greater than 0, so you have to plot a certain stuff. So you hold on. Decided to clear away the parts, and then we talk about it in writing. So you know that there is no coefficient of s, so this is why we say that this is a naught. Okay, there is 0 order, 0 of s, there's no or s, so it's 0 order. So it's actually k. Okay, like this. And then k should be larger than 0, so we have this set straight away. And then for the first order s, right, you have k plus 2 must be larger than 0, right? So if you bring this 2 forward, I mean over here, you have, so you will not change this thing, this portion over here will still be here, but rather than the plus 2 will become minus 2 over here. So this makes sense because if let's say 2 plus k, right? So if say your k is minus 2, it is equal to 0. Nonetheless, we don't want, but it has to be larger than minus 2, right? So let's say minus 1, then 2 minus 1 is actually 1, larger than 0. So I hope you get what I mean. So this is one key thing. And then you realize that the second order, okay, A2 is actually there's no k, so we just, that's it. So if you were to draw a number line, okay, so you have this number line over here, then let's put it 0 because everything, so this number line is taking the whatever values of k, okay, if k equals to 0, what is this or whatever. So let's say you have this, so let's plot. So in this case, A0 is actually k must be larger than 0, so we draw in this manner. So in this plot, k have to be larger than minus 2, so it is minus 2 over here. And then it's also going in this manner. So from here you can see that in order to satisfy this equation, okay, this whole equation, if you sub in minus 2, right, over here you have 0. I mean if you sub in larger than minus 2, okay, because if you sub in over here is minus 1, let's say minus 1, you have 1 over here, but if you sub in minus 1 over here, you have a negative, which is 0 to 1, right? So typically we want a range that can satisfy all of the boundary conditions that say that should be said or whatever. So in this case you can see that to satisfy the only range is stating that k equals to 0. So it's this range. So it's going to infinity. So this is the range. So this is the thing that I'm talking about. So if you were to compare to the previous one, I don't know whether they are deleted it. Anyway, so in the previous case, the third order, okay, it's the same number line. Just that you can see that it's also satisfying that all k is larger than 0. So this is why I shaded this area, stating that k should be within this region. If any smaller than minus Any smaller than 0, we are not talking about it anymore. So it has to be larger than 0, so we have this range over here. So typically if you were to draw a number line, make sure the first thing you draw is to draw a clear line saying that this is 0, and then the rest, it depends whether is it. So the region itself, you have to decide which region you are picking. Okay. So this also will have some marks. So make sure every step you do, you have to have a certain coordination. So what if it's first order? Okay, so let me hold on again. So let's say if you have a first order, and our transfer function is given as ks. Okay, the first thing we're gonna do is actually to hold on, no space. So the first thing we're gonna do is to develop the closed loop function. So we have this over here, and then it's equals to ks over 1 plus ks, and then you will realize that your denominator itself, it is a first order, right? There is only 1k over here. Okay, so therefore for k to be for this equation not to be okay, hold on a while. We write the transfer function as k divided by s instead of ks. Okay, so if you were to do up the same thing, the closed loop unity function, you have k over s divided by 1 plus k over s, and then you multiply the whole system by s. Remember, so this whole thing divided by s. I mean, yeah, multiply by s. So you have a k divided by this, so this will be s plus k, and then you will just throw away all this. Okay, I hope you understand. And then after that, since you can see that it's a positive, so it actually satisfy our equation stating our criterion saying that first and second order has to be have a positive coefficient. So in this case, our constant is actually positive. And then the second system, although it is not explicitly stated, okay, it didn't say that k has to be larger than 0, but you should know, it should be in your mind that say k has to be larger than 0, and therefore k is larger than 0. So if you have a number line with 0, so k has to be larger than 0. So there will be, so this range is straight away like that. You can, so this is why they actually didn't explain first order, because it's simply just saying that k has to be 0 and that's it, you know. And then you draw, maybe you want to draw a number line and then show this is the region, but k has to, you know, be this thing. But nonetheless, we have understood first and second order, and third order how we derive using a simple 4-step basis. Okay, and then in the next video I'll just talk about slightly more challenging one, which is the Routh array. So it is okay. So in the next video I'll just talk about it. So I'll see you in the next video.